Good day to you, students. How is the day going? Today we'll be dealing with chapter 9.2, gases and the kinetic theory. That is a subtopic under the kinetic model of matter. Let's start the topic. Gases and the kinetic theory. Understanding gases require the particles they are made up of. Gases can be better explained through the following questions. A. Why does a gas exert pressure? B. What happens to a gas when it is heated? C. What happens when a gas is compressed? We are to drag the following words into the correct boxes for the first activity of the day. Let's start. The particles of a gas move around inside its container, bumping into the sides. Doubling the number of particles means twice the mass, twice the density, and twice the pressure of the gas. At a higher temperature, the particles move faster. They have more kinetic energy. This is what a thermometer records at a higher temperature. So we check. That's correct. Now, compressing a gas. You can see that we have two major figures here, figure A and figure B. So let's use them to do the following activity by dragging the words into the correct boxes. The particles seen are trapped in a box. If the box is made smaller, the volume of the gas decreases. At the same time, its pressure increases. The particles of the gas has been confined to a smaller volume. They will collide with the walls of the container more frequently, creating an increase in pressure. If the gas is compressed to have its original volume, its pressure will be doubled. So let's check. That's correct. High-speed collisions. We are to use the following activity to answer this particular question. We are to drag the words also into the correct boxes. Let's start. Molecules of air around us move at speeds of the order of 500 meters per second, which is a little faster than the speed of sound in air. High-speed molecules rushes around in a room. They collide with the walls, the ceiling, the floor, the furniture, and everything. They bounce up every surface. And they also change direction. Each collision brings about a change of momentum of the air molecules. Each molecule that collides with the surface exerts a tiny force. Because there are so many fast moving particles and they collide with the surfaces in the room, they exert a large force. This is why a gas like air exerts pressure. Let's check. Correct. Boyle's law. The relationship between pressure and volume was investigated by Robert Boyle, an English physicist. The relationship Boyle found can be expressed in different ways. A. Doubling the pressure has the effect of halving the volume. 3 times the pressure gives 1/3 of the volume. B. The product of pressure and volume is always constant. PV is equals to constant. C. The relationship between pressure and volume can be expressed as the volume of a fixed mass of gas is inversely proportional to its volume, provided its temperature remains constant. This is referred to as Boyle's law. So, from the diagram above, in figure A and figure B, typically showing us that what? Pressure is inversely proportional to volume, and also pressure is directly proportional to the inverse of volume. With that, we are to drag the following words into the correct boxes. In figure A, the graph of pressure against the volume shows that increasing the pressure causes a decrease in volume. In figure B, the mathematical relationship between P and 1/V can be observed from the graph. This shows that pressure is inversely proportional to volume. Let's check. That's correct. Now, we are to answer the following question in relation to Boyle's law. So, let's start. A cylinder contains 50 cubic centimeter of air at the pressure of 120 kilopascal. What will be its volume if the pressure on it is increased to 400 kilopascal? So this is what happened. Don't forget that initially I said PV is equal to what? Constant, right? Let that constant be K. That means it is continuous. So I can have P1, V1 is equal to what? P2, V2. Now, if you look at the question closely, P1 is equal to 50. No, P1 is equal to 120 kilopascal because pressure is measured in pascal. V1 is equal to 50 cubic centimeter. Then we have to look for volume, that is V2, but we don't know. Yes, what we don't know is V2, but we know P2 to be what? 400 kilopascal. So here now we are making V2 the subject of the formula. So with that, we divide both sides by what? P2. So divided by P2 divided by what? P2. This and this will go. So since my left hand side can be made my right hand side, V2 now will now be P1 V1 over P2. With that, you now substitute your what? Your values. P1 is 120 times V1 is 50 and P2 is what? 400. So let's do it in the simpler form. 0 will cancel 0, 0 will cancel 0. 4 here 1, 4 here 3. 3 times 5. So V2 now becomes 15 centimeter cube or 15 cubic centimeter. Do we have 15 cubic centimeters? Let's pick it and check. That's correct. So with that, let's choose the correct statement in the following sentences. At a lower temperature, the particles move faster. They have more kinetic energy. This is false because at a lower temperature, particles tend to aggregate towards one another, having a stronger bond. So they will not necessarily have more kinetic energy until they are heated. That is when they can move faster. At a higher temperature, the particles move faster. They have more kinetic energy. This statement is what? Correct. Due to the what? Kinetic model of what? Particles and what? Atoms. Let's look at the third statement before we go. At a higher temperature, the particles move slower. That is not true. And we also say that they have more kinetic energy. That is false. So let's pick the second statement and check for the correct statement. That is correct. So with this, we've come to the end of this session. Do well to subscribe on www.edubbey.com for more of our interactive notes and video. Do have a great time. Bye.